we proceed to the chapter 5, size reduction. For chapter contents, this chapter consists of several topics, starting with principle and application of size reduction, grinding, cutting and slicing equipment, conclusion, exercises, and finally references. For learning objectives, at the end of this chapter, students should be able to A. Explain the principle and application of size reduction in food industries, and the second one is to differentiate grinding, cutting and slicing equipment. 5.1 Principle and application of size reduction. Size reduction in solid food particle. The definition: it is the breakdown of solid material through the application of shear stress or mechanical forces. Objective for size reduction in solid food particle. There are several objectives, starting with the extraction of desired component. For example, the extraction of juice from sugar cane. The second one is the product requirement. For example, for icing sugar and flour manufacturing. And number 3 is uniform mixing or blending. For example, for the uniform of cake mixer and also cake premixed. And finally, for process efficiency, where the smaller particle will reduce the drying, processing and extraction time. Shear stress in size reduction. The basic principle is to generate the shear stress to food particle in order to make it smaller. Shear stress can be generated by several ways, such as compression, impact, attrition, and also cutting. Stressing mechanism to cause size reduction are as below: crushing or attrition, shearing, crushing in a particle bed, impact at one solid surface, impact between particles, and finally shear action by the surrounding medium. Reduction ratio. Particle size is frequently referred as screen aperture size. Commonly used is the arithmetic average particle diameter obtained from the screen analysis on samples of the feed and product stream. This is a diagram of a mathematical formula that related to reduction ratio. Properties of food materials that affecting size reduction process. This is some of the properties of food material that affecting the size reduction process during milling. In addition, friability and attrition also contribute to the problems. Attrition is the actual unwanted breakdown of particles due to their corners or irregular surface being knocked off. Normally occur in food samples which have tendency of particle breakdown during storage and handling. Attrition is a serious problem in most of the food processes where dry handling is involved, since it may cause several problems such as formation of dust, health hazard, equipment damage, and also material loss. Milling configurations. Open circuit milling. It involves crushing or grinding that will give a large range of particle sizes. Open circuit milling is the simplest one, but it gives greatest range of particle sizes. It can be explained by this diagram. Raw material undergo the milling process and the product will be collected. As simple as that. Remilling. Remilling gives a more uniform particle size over prolonged milling. One size tends to dominate. For example, a raw material will undergo the milling process, and then the remilling process will be done for several periods after that, the product will be collected. Closed-circuit milling. Closed-circuit milling adds a separator or filter or sieve to reduce energy consumption to about 25%. Separation screen used for coarse particle and air separators for fine particle. The mill runs continuously, producing a uniform particle size. For example, raw material will undergo milling process and then sieve and remilling until the product will be collected. The application of size reduction in food industries. Depending on equipment, size reduction machine can be used on chocolate refining, flour manufacturing, and also icing sugar combination. So, as a conclusion, principle and application of size reduction in food solid materials are widely used in food industries involving several equipment that perform grinding, cutting, and slicing characteristics. Okay, this is some of the references.